tiles and tile maps overview, game development, and this is the example that we are going to be working on. This is the game. For example, if you press the keyboards on your laptop, on your computer, you can move horizontally, as you can see inside of these tiles, and you can go also vertically, so you can go down, you can go left, you can go up. So pretty much this is the game that we are trying to build this time. Okay, so this is the code that we are going to be following. So this is the HTML, and inside of that we have assets. So we have some files .png, so we have that, we have the other files and our assets. Then we have performance, so we have an HTML of canvas, against HTML, and then JavaScript. So we have this map here, so arrays here. Okay, this is in the performance folder, and then we have the square. In the square folder we are going to have HTML and JavaScript files. So we have the layer HTML, we also have a layer JavaScript, logic dash grid.html, and then again logic dash grid. Then we have no scroll HTML and no scroll JavaScript, scroll HTML and scroll JavaScript. So this is pretty much the code that we are going to be following. And if you wanna check it out, this is the person who wrote this code, so they already given us here, and you can check out this GitHub repository. You have all the code here in the GitHub repository. Okay, so tile maps are a very popular technique in 2D game development, consisting of building the game world or level map out of small regular shaped images called tiles. This results in performance and memory usage gain. Big image files containing entire level maps are not needed, as they are constructed by small images or image fragments multiple times. This set of articles covers the basics of creating tile maps using JavaScript and Canvas, although the same high-level techniques could be used in any programming language. Okay, so if you wanna, I don't know, try Python. Okay, besides the performance gains, tile maps can also be mapped to a logical grid, which can be used in other ways inside the game logic. For example, creating a path finding graph, or handling collisions, or to create a level editor. And as you can see, this is the game, and pretty much we're trying to, again, following this, moving down, moving up to the left, moving up, down. So we can try to, I don't know, maybe we can find a treasure, or this can be kind of like a similar to Mario. Okay, so some popular games that use this technique are Super Mario Bros, Pac-Man, Zelda, Link's Awakening, StarCraft, and SimCity 2000. Think about any game that uses regular repeating squares of background, and you'll probably find it uses tile maps. So okay, the tile atlas. The most effective way to store the tile images is in an atlas or a spreadsheet. This is all of the required tiles grouped together in a single map image file. When it's time to draw a tile, only a small section of this bigger image is rendered on the game canvas. The below images show a tile atlas, or 8x4 tiles. So again, this is pretty much the image that they're giving us, and you can pretty much appreciate it here in this file. This that tile underscore atlas.png. Okay, we have that. Using an atlas also has the advantage of naturally assigning every tile an index. This index is perfect to use as the tile identifier when creating the tile map object. The tile map data structure. It is common to group all the information needed to handle tile maps into some data structure or object. These data objects map objects example, and you can check out this link. Oops, let me check it out, so we can just leave that to start loading. Okay, these data objects should include, and we have the tile size, so let's check it out real quick. Okay, so this is the GitHub repository. If you click here, pretty much it's gonna send you to this link. This is the GitHub repository if you wanna follow along. If you click here, let me see, you're gonna have the assets folder, performance, square objects, and you are gonna have all this information you're gonna have all this information ready. You have the common.js, index.html. We have all this information here so you can follow along. Again, these data objects should include the tile size, the size of each tile and pixels across, pixels down, image atlas, the image atlas that will be used, one or many, map dimensions, the dimensions of the map either in tile across, tiles down, or pixels across, pixels down. Visual grid includes indices showing what type of tile should be placed on each position and the grid. Logic grid, this can be a collision grid, a pathfinding grid, etc., depending on the type of game. So for the visual grid, a special value, usually a negative number 0 or null, is needed to represent empty tiles. So we have here square tiles. Square-based tile maps are the most simple implementation. A more generic case would be rectangular based tile maps instead of square, but they are far less common. Square tiles allow for two perspectives. So we have the top down, like many RPGs or strategy games like Warcraft 2 or Final Fantasy World View. Side view, like platforms such as Super Mario Bros. Now we have the static tile maps. A tile map can either fit into the visible screen, area screen, or be larger. In the first case, the tile map is static. It doesn't need to be scrolled to be fully shown. So for example, in this case, well, we need to scroll down because it doesn't fit, but if I make it maybe smaller, so we have this. Now you could play without scrolling down or up, so this would be the whole game. But as you move to the right or to the left, you will still pretty much need to scroll down. Okay, so it doesn't need to be scrolled down to be fully shown. This is the okay. This case is very common in arcade games like Pac-Man, Arkanoid, and Sokoban. Okay, so rendering static file maps is easy and can be done with a nested loop iterating over columns and rows. A high level algorithm could be, so they're giving us this example here, and here we have the for loop statement. Okay, so inside of the for loop, okay, so we will have the let declaration. So we have this column and we are gonna initialize this column to 0, and then we're gonna have a condition. So as long as the column is less than the map that columns, we are gonna increment the variable columns by 1. Okay, and the block statement and the curly braces, we're gonna have a second for loop statement. And now we're gonna have a let declaration. We're gonna name it row, and we're gonna initialize row to 0, and the condition is gonna be as long as the row is less than the map that rows. Okay, as long as that is true, we're gonna increment the rows by 1. And inside of the curly braces, inside of the block statement of the second for loop, we are gonna have 3 constant declarations. So we're gonna have the constant declaration named tile, and we are gonna set it to the map that get tile, and we're gonna pass in the column and the row variables. Okay, to the next line, we're gonna have the variable x, so this constant declaration named x, and we are gonna set it to the multiplication of the column and the map that tile size. Finally, we're gonna have the constant declaration named y, and we are gonna set it to the row, to the multiplication of the row variable with the map that tile size. And then we are gonna call in this function draw tile, and we are gonna pass in the variables tile, the variable x, and the variable y. And this is pretty much an example how we could do it. So a high level algorithm could be, so this would be the high level algorithm. You can read more about this and see an example implementation and the square tile maps implementation. So you can you can check out this link, and when you can have more insight of this. So let's keep scrolling down. Okay, scrolling tile maps. Scrolling tile maps only show a small portion of the world at a time. They can follow a character like a platformers or RPGs, or allow the player to control the camera like in strategy or simulation games, positioning and camera. In all scrolling games, we need a translation between world coordinates, the position where sprites or other elements are located in the level or game world, and screen coordinates, the actual position where those elements are rendered on the screen. The world coordinates can be expressed in terms of the tile position, row and column of the map, or in pixels across the map depending on the game. To be able to transform world coordinates into screen coordinates, we need the coordinates of the camera, since they determine which section of the world is being displayed. Here are examples showing how to translate from world coordinates to screen coordinates and back again. And again, they're just giving us examples. So in the next video we're gonna start creating this game, but for now let's focus here. So we have some comments. These functions assume that the camera points to the top left corner, so we have this function named world top screen, and we are passing the parameters x and y. Inside of the curly braces of the function world to screen, we're gonna return an object with key value pair. So the key is going to be x and the value is going to be x minus the camera dot x, and then we're going to have another key value pair, so it's going to be y as the key and the value is going to be the y minus the camera dot y coordinate. So the second function is going to be something similar. We're going to have the function name screen to world, and we're going to pass two parameters x and y, and we're going to return this object x as the key, and then the value is going to be x plus the camera dot x position. Then we're going to have another key value pair y, and the value is going to be y plus the camera dot y. So we have that. And now we're going to be dealing with rendering. A trivial method for rendering would just be to iterate over all the tiles like in the static tile maps and draw them, subtracting the camera coordinates like in the world to screen example shown above, and letting the parts that fall outside the view window sit there, hidden. Drawing all the tiles that cannot be seen is wasteful, however, and can take a toll on performance. Only tiles that are visible should be rendered ideally. See the performance section for more ideas on improving the rendering performance. Okay, so this is the performance. So we will have this link if you would like to have more information. You can read more about implementing scrolling tile maps and see some examples implementations and square tile maps implementation scrolling maps. So we have this link as well. Okay.